we would appreciate a volunteer to take notes. Sorry, go ahead, Ron. All right. We do still need a volunteer to take notes during today's session. Okay, it's 5 minutes past the hour, so I think we should probably get started. We do still need a volunteer to take notes. Since no one has offered yet, I guess I'll try to do it along with running the meeting here. Melissa's not with us today. She's traveling today, so I'll be chairing on my own. Okay, let's dive into the chair deck. First, we ask everyone to be aware of the note well and review all of its everything that it says about how to behave here. Standard IETF boilerplate. And then let's get into the agenda bash for today. So the first thing up is to wrap up the deck on transport requirements that we started looking at back at IETF 116 and then continued working through at the last interim session. So there's one slide left on this deck. That's for Ecker to present, but he's not with us just yet. The other item on the agenda is Raphael Robert has a deck on transport versus delivery service. So I think what we could do, since Eric isn't here yet, is start with Raphael's deck and then come back to the discussion of the last slide of Eric's deck afterward. Raphael, does that sound all right to you?
Sounds good.
Okay. All right. So with that in mind, does anybody have anything else they'd like to add to the agenda? Okay. So in that case, let me throw up Raphael's slides and sorry, let me sort out the buttons here. There we go. Go ahead, Raphael.
Yeah, excellent. Thank you for drawing the slides. Yeah, so essentially this is in response to the discussion we had in Yokohama, where we now have a total of 3 proposals for various aspects of transport and delivery service and the protocol between providers in general. So and we don't really have consensus yet on what the scope should be exactly and what the architecture looks like. So in the last interim, we discussed a lot about very specific aspects of the architecture, thanks to Ecker. So maybe some of the questions in this presentation are no longer relevant. So yeah, in essence, I thought it would make sense to look at what the status quo is, what the general understanding is, have some discussion about it, and yeah, also try to explain a bit more what the understanding is regarding MLS specifically, because we already agreed that that is at the core of MIMI. But yeah, at times it feels like not everybody's on the same page regarding the architectural requirements of MLS. That being said, there are far fewer people here today, I think. So Jonathan Rosenberg is also not here. Or is he? Don't see him. But yeah, anyway, be that as it may, let's start with the presentation. So next slide, please. So yeah, so this is the 3 drafts we have currently. So linearized matrix, which I think at this point replaces the original matrix draft, which has also expired, I think, from Travis Ryerson. Then from Jonathan Rosenberg, we have the MIMI protocol. And from myself and Conrad, we have the MIMI delivery service. Next slide, please. And actually, did I miss anything? Please raise your hand if anything is missing. Okay. Right, so we have a little bit of consensus already in the sense that across these 3 drafts, there is this concept that a group or a conversation or a room, which is essentially the same concept, is owned by one of the providers. And that has to do, again, a little bit with how MLS works on one hand. And to separate the other providers in a federated environment. They're called other guests, or I think participants in the matrix draft. There also seems to be some consensus on the fact that the API in general is a RESTful one, with the one exception of the long polling in the MIMI protocol draft. So this is good. We have some consensus to start with around these things, but we need to talk more about the details. Next slide, please. So this is to illustrate what we just talked about. So there's the idea of an owning provider, which in this scheme here would be b.com, and then there's a guest provider. And the whole question about the transport and the delivery service is, how does a client that belongs to the guest provider, how does that client get to talk with the owning provider? Because ultimately, an action is initiated on that client, and it is reflected on the owning provider. So this is what we're going to look into a bit more. This, of course, would be a lot easier if there was only one provider, but then we wouldn't have federation and we would need interop. So this is what we're looking at. Next slide, please. So where do we not agree just yet? It's not entirely clear what we fundamentally want. So there was some discussion about a server-to-server protocol. There was also some discussion about a client-to-server protocol. And so this is where we diverge in the sense that there seems to be preferences, and we are not really looking at what the architecture actually requires currently. So this is what we need to look at in more detail. The scope of the protocol is also not entirely clear, in the sense that it's not clear what operation should be supported, what kind of data should be transferred, what state should be held by the server, etc. We also don't agree on the fan-out mechanism just yet. So we agree on the part where there is a RESTful API between either a client and a server or server and a server before the fan-out. But when the fan-out happens, the proposal in the MIMI protocol by Rosenberg is for long polling. Whereas what we proposed at least was push. I don't remember what Matrix is specifically proposing in that regard. So we need to talk about that. The other thing that is not clear at all is consumer versus enterprise. So we've discussed a lot in detail without saying exactly whether that applies to consumer messaging or to enterprise messaging. The assumption here is that a lot applies to enterprise messaging simply because all the people in the room discussing it work on enterprise messengers. And the question why that is relevant is actually the last slide that Ecker was supposed to present today regarding metadata. So this is the one fundamental difference that we need to look at. Maybe there are more operational things that have not really materialized yet, that we will discover, where we have differences between consumer and enterprise messaging as well. Okay, next slide, please. Okay, so I tried to summarize in very broad strokes what these three drafts mean, and of course it's opinionated, so feel free to disagree. So the way I understand it, linearized matrix essentially departs from this peer-to-peer deal that was in the initial submission for Matrix. So this is definitely more aligned with a consensus that we already have. From what I gather, it has a lot of dependencies from the rest of the Matrix universe, so things that are not actually defined in the document itself, references that are also not to other, sorry, apologies. It includes some things that we have not discussed in MIMI at all. which are, for example, that history is kept on the server. It also doesn't make it entirely clear what the metadata situation would be. So these are things we will have to look into. Next slide, please. So the MIMI protocol draft is pretty comprehensive at the time of writing. I think now we caught up a little bit with the other two. So in a way, it's a batteries included approach in the sense that it specifies an application layer protocol as well as a transport layer protocol, combines the two together, goes way beyond the scope of MLS in terms of functionality. So things that are like either adjacent or on top of MLS. And by doing that, of course, it blurs a bit the abstraction layers we could potentially have here. And as I mentioned earlier, it proposes long polling for fan out. And the open question here is how that would be compatible with Open Federation. So again, I just tried to look at the broad strokes from my perspective. Of course, all the details is not something we should look at if they're not relevant just yet. Next slide, please. So delivery service, that's one we submitted. That is not a transport protocol. And really, it only describes and specifies the messages between the client and the owning provider. And in the next slides, we'll see how that fits into the architecture. So specifically, it is agnostic of a specific transport protocol, which could be HTTPS, Matrix, XMPP, because all it does is specify how these messages look like and how they're being serialized. It's also agnostic of the question of whether we want client to server or server to server. And the idea is that it can cover both, like explicitly consumer and enterprise messaging. And the whole motivation behind it was to make the scope as narrow as possible so that we could get consensus on that. So essentially, it supports all the things you can do with MLS, but it doesn't try to go beyond that in the sense that there's a bunch of things we will probably have to specify for MIMI that go one level above as an application layer thing above MLS. So this is completely out of scope for the document. And just as a side note, we uploaded 2 new drafts in the past days for that. So it's a little more complete now. Yeah, next slide, please. So going back to the architecture question. So if there are different ways of looking at it. One would be to look at the providers and look at what would make sense from that angle. So that's not the one we choose right now. Like, I choose to look at it purely from a technical level and then see if we can make the ends meet somehow. So MLS has this property that it needs a delivery service that orders messages. And the consensus we have around that is that this message ordering happens on the owning provider. So on a very abstract level, that thing has a counter and it looks at commit messages that come in. And whenever the epoch number on the commit message matches the counter, then it's incremented by 1. Other messages are rejected for that epoch, etc. So this is fundamentally important. And this dynamic happens between the client that created the commits and the owning provider. So the client creates a commit, the commit somehow arrives at the owning provider, gets either accepted or rejected, and the client immediately learns about whether it's been accepted or rejected. The guest provider in that scenario is not super active. it doesn't really, like purely for the dynamic of sending a commit, the guest provider doesn't have anything to add to that. Yeah, next slide, please. So what the MIMI protocol from Rosenberg is describing is essentially a protocol between the guest provider and the owning provider as a server-to-server transport that is specified. And to me, that's not entirely clear how that fits in with MLS, because it doesn't really specify how the client actually takes part in this sort of exchange. The other thing is the guest provider sort of takes the place of the client here and has access to all data, which is a big question, particularly when it comes to consumer messaging, whether or not we want that. Next slide, please. So the last part would be the fan out. So when the client has sent a commit to the owning provider and the commit has been accepted, or any other message for that matter, then that message needs to be delivered to all the other clients. And in the first step, it will get delivered to all the other guest providers that are part of this one particular federated group. Essentially, like conceptually, this is a distinct second phase of the protocol. And this is maybe a little less controversial because now clients are not really involved anymore. This is truly a server-to-server protocol. And the only question is, what shape should it take? So again, the proposal from MIMI protocol is to have long polling here, where the guest provider would open a connection to the owning provider. And the argument for that is that this is very controlled, so it's good for preventing spam, because the owning provider cannot push out stuff to anyone. It needs to wait until the connection comes in. The counter argument is how does that work with open federation? Because you would have to establish connections between all of the servers in the world that want to participate in this. So the logical answer is this won't work with open federation. This only works when you have agreement between providers that they actually want to federate, and then they have these connections open. Yeah, next slide, please. So we handed in another very small draft to bridge the gap, simply because the delivery service we're proposing is not really a transport protocol at all. So what we propose is MIMI over HTTPS, and I understand that nobody had the time to look at it. And it's also not super important because all it is really is a wrapper for the delivery service messages to go over HTTP. Again, the delivery service is agnostic. This is now an opinionated choice to use HTTP. And then next and last slide, please. We try to lay out what the stack could look like. So since we seem to have consensus on HTTP in general, like all three drafts, at least not against it, so HTTPS specifically. And then the question is, what do we have above HTTP? And so what we're proposing here would be to have this really thin layer to wrap these messages over HTTP for the delivery service, which in turn is a bit of a wrapper for MLS messages and aggregates a few more things with that. But you could also have discovery, which is in scope, but we're not talking about it just yet, on top of MIMI over HTTPS. There could be other things. So this is essentially a proposed stack of how that could work, so that things are as modular as possible, in the sense that if we have something else that could simply live on top of MIMI over HTTP, then again, if we want to use a delivery service over a completely different protocol, that could also work. Yeah. So yeah, I hope that was helpful to look at some of these aspects. And I think that was it from our presentation. I'm happy to take questions, which nobody asked during the presentation, which is surprising.
Yeah, it is a little unusual. It's usually a very chatty group. Thanks, Raphael. So yeah, the queue's open if anybody wants to ask questions or comment on any part of this. Go ahead, Travis.
So the mention of like linearized matrix and all that, we do have a sort of work in progress draft. It hasn't been published yet. That removes all the dependencies from the existing matrix system, because I definitely agreed it shouldn't depend on a lot of that. We're also just working on tying it to MLS. This is a sort of brief update there, just to sort of add the additional context.
Yeah, makes sense. I suspected as much, but since I didn't see it in the draft. It's terribly quiet today. Let's maybe see if we can ask some questions. How do folks feel about scope? Is there a preference or good arguments for having a larger scope and having like a batteries included approach, where you have one big document that specifies nearly all of the aspects, or do folks prefer a more modular approach?
I guess I guess at risk of just also monologuing a bit, I think the sort of batteries included approach would probably be a bit better in that sort of sense, because if it becomes too modular, then we might end up just trying to design the world, grains of sand at a time sort of idea, whereas having a sort of single or larger document, it might be a little bit easier to work through.
I think the important thing is whether there is a document that shows good examples of that kind of gives the big picture. But the part that I think that has not been done in any other set of documents from any of the other authors is how how MLS specific things which have impact on the clients and on the server to server interface, that we have those things are easy are accessible, are easy for implementers to understand. So I think that the MIMI over HTTP draft, I think that could be separate and you could refer to it, but I don't have a strong opinion one way or the other on that one. But the delivery service draft, I think, is really, really important.
Yeah, thanks, Ron, for that. So yeah, just to reiterate on that, since also nobody's in the queue, the idea behind the delivery service was really to only specify stuff that eventually will have to be specified in any other draft as well. It's not stuff that is specified in the linearized metrics yet, nor in the MIMI protocol, at least not fully. But if those documents at some point, they would get to the point where they would have to do exactly that. So there, again, the idea is to extract that and have that as a separate thing, as a common denominator, essentially, and push a lot of the other things that we have in MIMI protocol, for example, like having clear text usernames on the delivery service and stuff like that, to push that away and to have that on top of MLS, if that's what we want, obviously. But in the last session, we also said very clearly that we want to actually harness MLS in terms of cryptographic guarantees it can give us for things like access control policies and other things. And we shouldn't hand out completely unverified plain text data between servers.
So I remember this discussion of encoding permissions and ACLs and so on at the MLS layer. And I apologize, I'm not an expert on MLS or really how it works. There's one thing I was wondering though. Is that like a question of the layer of the stack at which ACLs are represented, or is there some way in which MLS can actually cryptographically enforce that participants in a group are like complying with the ACLs that are expressed at the MLS layer?
So when you, or Ron, maybe you want to go ahead on that, or is it related to something else?
Yeah. So the agreement of MLS says that everybody, like if you had a policy document that describes what the policy is, what the admin policy or the group joining policy or whatever it is, then you can share that with every member of the MLS group, and you can be assured that everybody in the same epoch sees the same copy of that document, and then they can enforce. Then any individual person can go and enforce that. It doesn't say, it doesn't define what the semantics are of that document. It just says if you have an extension and you want to be able to convey that information and get agreement on it, this is how you do.
Okay, so it sounds like you get like a cryptographic guarantee that all of the participants have the same view of what like the agreed upon ACLs are, but of course you can't prove that like individual clients or servers actually did then go enforce those ACLs.
Exactly.
That makes sense. Thank you.
Yeah. So and what's derived from that is the fact that the server cannot just add someone as an admin without clients noticing. So this is another guarantee we get out of that. Unless we specifically, give the server the right to do so, but especially in a federated environment where you have several servers, you essentially don't have to rely on all of them, but only on those that you specifically choose who can add and remove people. So again, you have owning providers, you have guest providers. The guest providers, for example, then they don't have the right to add or remove people from a group because they're guest providers by design. So all of these nuances can be expressed and actually enforced. Right, go ahead.
So Raphael, maybe if you wanted to open up the latest version of the draft, since it's fairly new, does anybody object to maybe walking through the top 3 or 4 things that are likely to get someone who doesn't have a lot of experience with MLS? Like these are things that you need to be aware of, and what the DS implications are in your draft.
Yeah, I think we could do that. Tim, is that something you would be able to share, or maybe it's better if I share my screen? Let me see.
Yeah, here, I'll stop sharing slides and then you see if you can share your screen. If that button doesn't work, then we'll figure something out.
Yeah, give me a second. getting there slowly.
While we're waiting on this, as it turns out, Eric Riscorla won't be able to join us today, but we still could take a look at that last slide in the deck, which has to do with privacy metadata, since after, of course, looking at this draft. Raphael, I think you already broached the topic of metadata privacy when you were talking earlier, so I think perhaps we could still have a useful discussion.
Yeah, the two are actually pretty linked, so that's a very good point. Yeah, I'm really sorry. I'm having trouble sharing my screen here. Since Ecker is not here, I'm blaming Firefox.
If this doesn't work, I'll try sharing it from my end. If you can point me at the, oh, I see it. Yeah, it's the one you updated earlier today.
Yep. No, sorry, this is just not responsive. Sorry for that.
All right, let me give it a try. All right. Can you all see that?
Yeah.
Is that the right
Looks
draft?
good. That's definitely the right draft, yes.
Okay, sweet. All right, then I guess just let me know which part you'd like to look at and take it away.
Yeah, if you can scroll down a bit past the introduction. Yeah, so regarding the flow, that's what we already touched on in the presentation a bit. So what this specifies at this point is the messages that go from the client to the delivery service. And the delivery service here would be the owning provider. So this is way more abstract than in the presentation. But simply to illustrate that this is a request response scheme. And in phase 2, there's a fan out between two delivery services from provider 1 to provider 2. Again, this is where we have the proposed long polling in the MIMI protocol, and where we are proposing a push mechanism. So this particular part is not specified in the document just yet. The initial approach was to just have a very high level, but then the feedback we got was that folks don't really understand what we're trying to achieve here. So now we've added some more. And if you can scroll down a little more. Yeah, thanks. So the whole idea is that the client can also authenticate to the delivery service in a way that is specific to the group. So authentication across borders of federated systems is always complicated because how do you share trust, etc. So this takes away a lot of that problem, simply because when you start with an established group, a client that interacts with such a delivery service is a client, is a member of that group. So it has cryptographic key material as part of the group that it can actually use to authenticate. And depending on what the operation is, the authentication is slightly different in how it works. But just to give you a very concrete example, in MLS, every member has a leaf node in this ratcheting tree, and the leaf node contains a signing key that is specific and unique to every member. And so when you want to authenticate and to prove to anyone that you are part of that group, you can simply reuse the signature key to sign anything. And so this is the mechanism we're using here. These requests from the client to the delivery service, they're simply signed with the same key that is also being used in MLS. And that allows the delivery service that holds this ratcheting tree as a state, as group state, to actually identify clients and ascertain that they're indeed part of the group and that they're allowed to send commits and send application messages, etc. So we don't need another layer of authentication in that sense. It's a little more fine-grained because not every operation is necessarily a signature, but this gives you an idea that the authentication is essentially completely decoupled from any other authentication you might have on the system. You don't need a username and password to log in or to share credentials, etc. Yeah, if you scroll down a bit further, request response scheme. So yeah, what we're proposing here is to simply mimic what we already did in MLS in terms of how we structure these messages, where we use C structs and then we serialize them with a TLS codec that has worked really well for MLS. This is what we're proposing here, simply because this is very close to MLS. So the code of the application that would deal with the delivery service would also be, sit right next to the code that deals with MLS. So we wouldn't depart from that logic, and then we don't have to have a debate about whether we prefer, JSON or protobuf or whatever. And the next part is actually looking at the operations in detail. So again, these operations is what we think is the common denominator for any system, simply because it's an exhaustive list of things you can do with MLS. There's more stuff you can do on top of MLS, but again, that's not in scope for the delivery service. So the next part here is not super fleshed out, but the idea behind it is that there is a C struct for every request with a bunch of parameters that are needed to send from the client to the delivery service, and then there's a response that you get back immediately. What's also needed is instructions for the delivery service on how to handle these messages. So the delivery service has the public group state, meaning the ratcheting tree, which is this binary tree for those that are not particularly familiar with MLS. It also has an object called the group info, which is comparatively much smaller than a ratcheting tree typically, which contains a few more things that clients need in order to be able to interact with the group. And that's pretty much it from an MLS perspective. So whenever a client sends a request to the delivery service pulls up the group state, authenticates the client, and then looks at what exactly the client wants to do, and can perform that operation and tell the client whether or not it worked out, and ultimately fan out the message if that's what needs to be done. So yeah, if you scroll a bit further, so I'm not going to go over group creation and deletion. So maybe not that much if you go back a little bit, joining groups. Thank you. So joining a group, there are different ways of doing that with MLS, and ultimately it comes down to whether somebody who's already in the group sends you a welcome message, or whether you discover the public group state, and then you can, depending on the policy, but you can insert yourself into the group, if you will, and the mechanism for that is called external commit. So this might look surprising, as Rowan said. This is really the MLS terminology kicking in here. So when you receive a welcome message, what you need is the ratcheting tree that is on the server. Same with the external commit. There you need the tree first, and then you as a client, you issue an external commit to insert yourself into the group. And maybe I should say a bit more about the group state and the ratcheting tree. So the server has that, and by observing messages that come in and out, like commits specifically, the server can actually update this ratcheting tree. So every commit covers so-called proposals, and the proposals then say in what way the tree should be modified. So an add proposal, obviously, like the name says, proposes to add someone to designate a location in the tree, and the server can essentially update the tree in the same deterministic way that the clients will also update the tree when they receive the commit later on. So there is no reason that the clients actually have to constantly update the tree on the server. This happens automatically. And it's a very convenient mechanism to have whenever a client joins a group, particularly when the group is larger. So MLS is about scalability, and the question is how, on a cryptographic level, but the question is how can we make scalability happen? What needs to happen on the server side, and that's exactly it. The server is essentially assisting clients here whenever they want to join a group, because it could be prohibitively expensive to, whenever you add someone to a group, to also upload the whole group state, the whole ratcheting tree from a client to a server. So yeah, so these are on a high level, these are the two operations on how you can join a group. And they can be initiated differently with different proposals, but like the joining client, it's either one of the two in the end. The next part is rather trivial, adding and removing users. So that's one of the core functionalities of MLS, is to add and remove users to the tree. So what happens here is simply that the client, in the case of adding users, they're added with so-called key packages. So key packages, for those who know the Signal protocol, that used to be called pre-keys. In MLS, it's called key packages. In PGP, it's called public keys. So essentially, it's the public key material of a user that you need here. So when you add a user to a group, all you do is essentially you tell the group, here's the key package of the new user. This user is now in the next free leaf. So everybody will calculate the same leaf index in that tree. And so that's how the user is now part of the group. And in turn, the new user will receive this welcome message that allows them to then sync up cryptographically and be cryptographically part of the group. Removing users is even easier because you can reference them by the leaf index in the tree. And so now last time we spoke about policies, and Tim just mentioned that. So this is where policies would essentially kick in and determine whether or not a particular user can add and remove other users. Fundamentally, MLS is like full anarchy. Anyone can do anything unless we agree to have specific rules. And now these rules can be observed by the clients. They can also be observed by the delivery service. If they are in clear text, if it's an extension to MLS that is in clear text, the server can enforce that as well. Ultimately, it's important that the clients know about it, but it can be very convenient if a malformed add proposal gets already stopped at the server level. Right. The next part is adding and removing clients to and from a group. So MLS doesn't care much whether members are users or they're clients of users. They're just members at the end of the day. However, we care because they're fundamentally different rules. So you might not be an admin, but you are still allowed to add a client that belongs to you to the group. So this is why we need to differentiate here. Ron.
Yeah, and if we support publicly, public groups, then we would also, you could be in a public group where you would need to maybe show that you have some identity, but then you could just join and start. You can join in the same way, even if you're not an admin.
Yeah, makes sense. Right, updating clients. So this might sound surprising for those who are not super familiar with MLS. MLS has this cryptographic property called post-compromise security, and what that means is that clients update their key material regularly so that they can actually recover from a compromise. And this is where that operation is expressed. Clients can refresh the key material by uploading a new leaf node with fresh key material and replace the old one in the tree. This is what's happening here. And that's a dedicated operation because it doesn't really have any other particular effect. While doing so, of course, they can also upload more stuff that's part of the leaf node, not just the key material. They could introduce a new signing key, for example, if they have a new certificate. They could propose a new extension and whatnot, but fundamentally, this operation updates their leaf node. And if nothing else, there's only just new key material. Resyncing clients. So this part, I believe is going to be very important because we've heard from a lot of people who implemented the Signal protocol previously that things just go out of sync. And that's not specific to the Signal protocol at all, but it's the only protocol that has been deployed at scale for end-to-end encryption. And it's the first time that we have cryptographic sessions at scale that last really long. So with TLS, sessions are typically very short, so we never had the opportunity to witness that necessarily. And even if it happens, then you just tear down the session and do a new one. Yes, Tim.
So you say Signal is sort of the only example we have to look at here, but like there are other E2E encrypted systems, like I guess iMessage off the top of my head. I guess, do you mean Signal's the one that like where the details of it are public and where there's maybe a substantial body of research on people's experience running it?
Yeah, that's a good point. I mean, iMessage clearly is there. Then again, Apple doesn't usually share a lot of information on these internals, so that's a good point. So Signal is not the only one technically, but Signal is the one we heard from a lot.
Yeah, and where there's a body of literature on it. Okay, thank you.
So yeah, again, it has nothing to do with a specific protocol. It could be iMessage, it could be anything else, whatever Threema is using, for example. Yeah, but the fact remains that you have long-running sessions, and you have bit flips on devices, you have faulty memory, you have all sorts of things that at some point materialize. And what you need then is to be able to restart a session. And the big question is, how detrimental is that to security? And particularly with MLS, it's a little more complicated because now we have group sessions. So if things fail at a group level, then you're out of the group immediately. With one-to-one protocols like Signal and others, it's more granular. Like for example, you're no longer able to decrypt messages from a specific participant in the group, but others still work. With MLS, it's pretty radical. You can quickly tell when you're out. because none of the messages you receive can be decrypted. So long story short, you need a mechanism to actually recover from that. And this is what resyncing client stands for. It's generally not super complicated thanks to these external commits. So the thought behind it is that you actually leave the group and you rejoin it in one operation with one of those external commits, as if somebody had just invited you to the group again. So the remaining questions are questions about authentication in that context. But mechanically, if you have still access to the server, assuming that not your client has not been wiped completely, then you can actually resync the MLS part here. Right, next operation. And by the way, so I strongly believe that resyncing is something that has to be part of every mature protocol. Like anything you want to deploy in production at some point, you have to think about resync. You cannot really say, yeah, we'll see when it happens, because it will happen at some point, and then you have nothing to recover from that. Yeah, next one is updating client fanout information. So this part is not super silent just yet. Essentially, the delivery service can also store information that is relevant for the next phase, the fanout phase, and it depends a bit on how that phase is going to look like. But this is to say that the state required for that can simply be part of the delivery service state, and clients have a way to update themselves in that sense. Yes, Ron.
I think for resync, I think it might be confusing. You're not talking about a reinit. You're talking about a participant joining and that had previously been in the group, but doesn't have one or more epochs in between.
Yes. So just to disambiguate the terminology, reinit is like restarting the whole group for everybody and discarding the old one, the MLS terminology. For example, when you want to, I don't know, upgrade the Cypher suite. So you reinit the group in the sense that everybody gets added to the new one, everybody knows about it, everybody discards the old one. Resync is specific to the client. So it's only the client leaving the group and adding itself to the group in one operation.
So I think that resync has a bunch of baggage associated with it, particularly around history. Just a thought, if we called it rejoin, I think it would have the semantics that you want, but it wouldn't have the baggage of you're including all the history that you lost.
Right, yeah. So yeah, the history and other things are clearly out of scope here. That's a very good point. So it might be the case that the client missed a lot, depending on when it got out of sync and when it took action to get back into sync, or to rejoin, to use the new term. So yeah, makes sense. We can rename that if you have a strong feeling about it. But I think we agree on the scope here. Scope is purely, again, on the MLS level. How do I get back into the group? Right. Yeah, if you could scroll a bit further, Tim. So I think that's pretty much it. Sending a message. We skipped over that part. Of course, you can send actual messages, text messages, whatever the content is going to be. That is what the content format protocol is going to determine. Ultimately, there's not much to be said about that. So in the MLS jargon, they're called application messages, just to distinguish them from commit messages. And they contain free format bits, essentially. And they don't have to be ordered within an epoch. And if applications agree, they can even also be unordered outside of the epochs, meaning that you could still receive application messages from previous epochs. It's just a matter of agreeing on that and keeping the key material around. And of course, they're sent in O of 1. So a client creates one application message, hands it over to the delivery service, and the delivery service multiplies that message and sends it out to everybody. There's no individual one-to-one encryption anymore. Right, the next part is the queuing service. So this is there's probably going to be more discussion on that. The queuing service is the fan-out part, and maybe we need to rename that. Maybe the terminology is not good enough here. But it pretty much boils down to a delivery service receiving a message, whether it's commit or application, accepting it, and then looking at its own state and determining who it needs to send it to. And if it's local users, then we don't need to specify how that works. However, if it's users on another server, another domain, then we need to specify how this message gets there. And the most straightforward proposal here is to have a push mechanism on how to do that. Yeah, I think I want to punt on more details about the queuing service at this point, because this is really only salient once we actually get there. Ron, go ahead.
Yeah, we at IETF, we have people with a bunch of experience in a bunch of different domains. I think this is one place where this is a great place where we can call on experience from, from people who have not been maybe like super active in other areas, or that, people on the IAB or ISG who have a little bit more of a broader view. There are tons of these, message bus architectures, Kafka, like Jetstream, NATs, there are tons of these frameworks that people use to go and deliver things from one machine to another. And I was unable to come up with an IETF standard approach that seemed like it offered similar functionality. Anybody here want to say a few words about that, or have a suggestion of, is there a thing we can just kind of off the shelf use?
Since nobody's picking up, so maybe the question here, or the challenge, will be to figure out how much is in scope. How much do we even want to specify here for interop? So far, it's been relatively easy for the delivery service, because you can argue that everybody will have that problem. Here, we have to see whether we want to specify a full protocol or just message structure. To give you an example, one extreme variant could be like a fire and forget sort of thing from an interrupt perspective, where you only specify the wire format of the message. Another variant, to go to the other extreme, could be an interactive protocol where the guest delivery service actually responds to this fan out with meaningful information, saying, for example, hey, this client no longer exists, or the user no longer exists. So we might actually, be interested in this sort of thing, to get this feedback, because the owning delivery service might not have an accurate view at all on what's happening on other servers, because there is no other, protocol to synchronize at this point. So it might rely on feedback from other servers saying, hey, this user is gone, remove it from the group or whatever. So yeah, that's fundamentally the scope. But I'm not particularly worried about it just yet, because this will be details we can talk about. Yeah, I think that concludes that document. Maybe for the sake of completeness, if we take a really quick look at the new MIMI over HTTPS, just to complete the picture.
Sorry, you mean a different draft, Raphael?
It's a different draft, yes. We just uploaded it right before the interim here.
That should be here then. The MOH00 here?
Yes, that one.
Perfect.
Excellent, thank you. Yeah, if you can scroll down a bit again. Past the boilerplate stuff. So, yeah, this is really small. And the idea here is to see what we need in terms of standardization at the HTTP level. So this essentially has two interfaces. One for the first phase, where you have this client-originated request that comes in, and the other one is for the fan-out phase for now. So all of the things we discussed, like adding users, removing users, etc., all these things that pertain to a particular group, they go, I think if you scroll up a bit, yeah, process group message in 131. So this is one endpoint that receives this delivery service message, and that does the processing and gives back a response. So the other endpoints, they're essentially just to receive, for example, welcome information when you're not yet part of a group. So technically, that's not really interacting with a group just yet. And yeah, so the idea behind it is these endpoints have names, have a specific content type they expect, and the body is really just the TLS serialized request from the delivery service protocol. And the same goes for the response, and that's pretty much it. If you scroll down a bit more, yeah, so welcome external commit information, that's what we discussed earlier. This is when you want to join a group, you need to request that information. There are things where the server can sign stuff, and that's why you need a verification key. So for example, the server can sign or issue a remove proposal in the context that I just explained earlier, where it receives feedback that, for example, a certain user no longer exists. It can actually issue a remove proposal that is then committed by one of the clients, and MLS says that every proposal always needs to be signed, even if it comes from the server. So that's why you actually need to know what the signing key of the server is. And that's the endpoint to retrieve it. And so we didn't really speak about the details of one-to-one groups versus regular groups. We did in the last interim session, and or even the one before, I'm not sure. And it seems like there's some initial consensus that in order to avoid abuse and spam, we want to only be able to add people to groups if we already have a one-to-one connection with them. And if we don't, we cannot add them to a group. This is something, if we come to that agreement finally, that we can relatively easily represent with MLS by simply having two categories of key packages one that is publicly available to anyone, and that's good enough for a one-to-one connection that needs to be accepted by users. And another category that is not available to everyone, is only available to people you have a connection with. And those are also marked with a special extension so that you cannot confuse the two, essentially. Like you cannot take a key package for a one-to-one request and use that to add someone to an actual group. So what is in scope also for the delivery service is to make these key packages available. And this is how you can retrieve them with the connection key package retrieval. And if you scroll down a bit more, there should be another way to retrieve them. Yeah, the group key package retrieval. Yeah, one really important point is rate limiting, and we'll also get back to that when we talk about metadata privacy. If we really aim for open federation, we need to be really careful about the ways the system can be abused. And so we already talked about how the authentication works. And so we have actually several layers of defense here in terms of rate limiting. One, which is completely out of scope, is of course IP addresses, but every request for a group is now specific to a group, obviously, and every group has a group ID. And so we can rate limits on group IDs. Furthermore, within a group, most of the requests, they're specific to a certain member in the group. And then we can also rate limit on the leaf index of the specific member. So you can relatively easily, at the DS level, have rate limiting for sending messages, because you can say, you know, user X in group Y, you know, has already sent 10 messages in the past 5 seconds. Now we need to throw that down a bit. So we don't really lose our ability to do meaningful rate limiting in this kind of architecture. Right, yeah, so that's that document. Maybe there are more questions around that before we jump to the privacy stuff.
Yep, the queue's open.
No, okay. It's
I guess it's
different vibe today, I
presentation
have to say. All right, so
Okay.
we had this one slide from Ecker that was left, right?
Yeah, exactly. And in fact, when I spoke to him, he suggested that you, Raphael, will probably have a fair bit to say about it. So let me pull that up. Yeah. At last, the very end of this deck. Right, yeah, so it seems like last topic to discuss here is privacy for metadata.
Excellent, yeah, thank you. Yeah, this is a vast subject. It's a complicated subject, and one that arose very early before the charter was finalized to understand whether this is in scope or not. From my perspective, this is really important when we talk about consumer messaging. This is a lot less important for enterprise messaging. And since consumer messaging is very much in scope for MIMI, I want to say this is also in scope, and it's something we have to think about. So going over the bullet points here, MLS mostly protects the content of messages. That is true. It's a protocol for end-to-end encryption, and it's designed for key agreement and using these keys we agreed upon to actually encrypt messages. In addition, it has two kinds of messages, or two versions of messages. They can either be public or they can be private, and that applies to proposals and commit messages. And the private ones, they're additionally encrypted, essentially, to give some more privacy. So this is one way how MLS could be used to have metadata protection at the message level, because the header is also encrypted. So there's very little you actually see in clear text. It's the group ID for the message. But for example, you don't see who the sender is of the message. You first need to decrypt the header, and then in the decrypted header, you can see who the sender is, and then you can derive the key material to decrypt the rest of the message. So this is one mode that gives us protection at the message level, but only having it at the message level is not good enough, because by talking about that, we conveniently disregard that we also have to route messages from A to B, and in that context, we need metadata again. So that it's certainly not the full solution. So what is metadata? And Ecker seems to give some examples here, which is all more or less the same. So who is messaging who, meaning who is the sender of a message and who is the recipient. Channel membership, so group membership in the MLS jargon, which sort of overlaps with who is messaging who, because typically if people are part of a group, you can already infer that they're messaging each other if the group is not completely dead. Contact lists, I guess that is out of the specific scope of groups and probably more on a user level, I assume, where users have contacts in general. You could also see that as the sum of all the one-to-one groups you have with other users. Now the question is, are we going to do anything to address that? And so what we've been working on is to see, and when I say we, it's Conrad and I, to see if we can come up with a variant of the delivery service that still lets us do all the things we want to do, meaning, adding, removing people, joining groups, having this server assistance, etc. And so to make it short, the outcome of that research is that what we can do is we can have pseudonymous groups where we still have all this group state on the server. However, the server doesn't really know for sure who the members in the groups are. So it sees that there is a group with a definite set of members, but it doesn't see the certificates, for example, of the users. So it greatly reduces the amount of metadata that a server gets to see, because it can only anonymously collect messaging patterns in that group. So it still sees that member 1, is an active member in the group, whereas member 2 hardly ever sends any messages and stuff like that. But it cannot really correlate that with other identities, like real-world identities or identities from some sort of an identity provider. So we believe that we can do the delivery service in 2 flavors, essentially, and the difference are relatively minimal in the protocol. They're a little more substantial in how the delivery service works internally, but at the protocol level, it's going to be relatively minimal. And it's very much like we have already done it with MLS, where we have these public and private messages, where one is encrypted and the other one is not. So it would be very similar to that. It would also come with more explanation on the architecture as a whole, so that while we strip away some metadata, we don't add it again later. For example, if we end up not really specifying how the fanout works, then that might be one of the areas where we need to be more specific going forward when we want to do that. Yes, Ron, go ahead.
Do we, I can totally imagine that some people who want to deploy a messaging system want to have more metadata for various reasons, or may even be required to have some. And also, lots of services that would be very keen to have limited metadata, or no, the minimum possible amount of metadata. I guess the question is, how do these systems interoperate, where I have one that is a sort of a metadata loving system, and a metadata phobic and metadata philic systems? How do those two figure out what to do?
Yeah, no, that's a good question. So the underlying assumption here is that nobody's forced to do anything. Like, if you don't care about the metadata minimization, you simply don't do any of that. And to a degree, it's an open question you're asking, but in the sense that we cannot fully answer it. But my understanding so far is that the interrupt that we're discussing is always on a group level. So if you want to interrupt for a certain group, then you have to follow the rules of that group. And if it's an enterprise group, then you know what protocol to pick. Whereas if you want to interrupt with another group, then you have to follow those rules. So we have not really expressed anywhere what kinds of groups we have, and how that works, and how that is advertised, etc. But I would see the separation strictly at a group level. Does that answer your question, Ron?
You mean like based on the owning servers preferences? That's who you think would decide?
Yeah, I mean, a group always starts on an owning server. Like when you as a user, you create a group, you create it on your server. I mean, that's at least the understanding we have now, that you don't create it on somebody else's server. You always create it on your server. Now, that makes your backend the owning backend. And now the next step is you invite other people to that group. And the context of that invitation has to make it very clear what kind of group it is and what kind of protocol is being used for that group. And then either, and it might be the case, that we want to advertise that in extensions of key packages, so that we can actually negotiate the capabilities. And then you can tell by a key package whether or not it's fit to be in that particular group. In the same way, you can look at its support for Cypher suites today already. Yeah, Mallory, finally somebody who is not Rowan. Excellent. Go ahead.
Sorry, my microphone didn't want to cooperate. Yeah, no, I've been paying attention. I think that your draft has been good, but I wanted to comment on this. From my view, it would seem that even though this may be up for debate among specific implementations, different use cases might come forward with different configurations. I would think that the IETF's work on interoperable messaging to define what is the sort of bare minimum requirements would be helpful, so that when implementations kind of sort of depart from that, that is then sort of their choice, right? Or there's a distinction between this is the metadata that is at minimum required to run an interoperable messaging service, and everything else on top of it isn't required, but is tied to features or other kinds of services that particular provider has chosen to implement. And so I would, because I feel like this topic is so important, I think that's the way that MIMI should approach talking about it. That's it.
Yeah, thanks. At this point, at least, I feel it's relatively binary in the sense that you have to decide ahead of time whether you care about metadata protection or not, and then pick that one flavor and instantiate your group. I don't think, but this could change over time, but I don't think it makes a lot of sense to say the minimum level is always consumer groups, because they have next to no metadata, and then we can build enterprise groups on top of that. I think the price would be too high to pay for enterprise vendors who really don't care about consumer messaging at all. But we'll see. I mean, at the end of the day, we will have a protocol that is super detailed to look at, and then that's better to take a decision based on that rather than some gut feeling that I have right now. Yes, Tim.
Yeah, thanks. So it does seem like perhaps a lot of the tension here is introduced by the notion of wanting like consumer messaging to interop with enterprise messaging, because it's intuitively there are just different expectations from like the operators and the users of those systems. I think about things like privacy. What I mean is that like if I join my employer's Slack, I mean, I understand and to some extent like agree to having some like either the messages themselves or metadata about them be visible to my employer. So I wonder, I don't know, I wonder whether maybe it's too big of an ask for this working group, right? To say that like, yeah, we'll work out a way that you can have like iMessage interop with Microsoft Teams. Because I wonder whether a protocol that can capture both of like the consumer and enterprise models, like if one protocol can reasonably solve both.
Yeah, that's a very good point.
I have an answer for you.
Shoot.
So one of the reasons, I mean, this is in fact one of the reasons why the DMA was created. If you look at the language carefully, it actually talks about provide your European providers being able to get access to customers on, what turn out to be basically consumer messaging systems. But let's take the case where you have a stockbroker and their customers. So they've been getting in trouble because their customers are contacting the stockbrokers using WhatsApp, for example, and trying to do trades. And so this is a classic case where you have a user that is using a consumer surface that wants to talk to somebody who also has an enterprise messaging system, because they have a customer, supplier or customer, provider kind of a relationship.
Yeah, I see.
The question is though, which protocol gets chosen in the end, right? So you have a consumer talking to a company. Is that going to be on the consumer protocol, or is that going to be on the enterprise protocol? That's definitely something to think about. My gut feeling here would be that would be the enterprise protocol, because it's
Maybe
fundamentally Go ahead. Sorry.
Maybe it's the MIMI protocol with the right intersection of settings. Basically, this is what I'm able to do. Are you okay with that? And if that's not what your default allows, the consumer messaging system says like, hey, you're being asked to go and comply with this thing that says that you're going to be recorded. Are you okay with that?
Sure. If we get to a point where it is, so fine-grained that we have, like a slider between privacy and I don't know what the other end would be, then yes. But again, right now I see it as a bit of a binary thing where you cannot just, granularly strip away the metadata from the enterprise variant. Like either you do all of it or you do none of it. But maybe we get to that point. Yes, Travis, go
ahead. Just on this, the I guess rough idea for a protocol would be that it should be able to handle as little metadata as possible, just enough to deal with moderation or trust and safety, because it's always easier to add metadata than it is to remove it, which I think is what you're kind of referencing there by having enterprise and consumer being on sort of separate ends of a scale there. Ideally, I believe the protocol that MIMI ends up accepting should be dynamic and able to actually support that idea, being able to have the minimum set of metadata to just operate, and then being able to slide that up rather than slide it down, if that makes sense.
Yeah, I fully agree with you on a fundamental level. Like, if you want to design something, that is secure and or private, you start from there and then you add stuff. You cannot go in the other direction. That never works. However, in this particular instance, we don't have the luxury of having no metadata, simply because we need the metadata for routing the messages, for preventing spam and abuse. And the question is only whether the metadata is pseudonymous/anonymous or not. So that this is the degree of liberty we have, is to take away like the real life identities, to take them out of the system. And doing so requires a bit of work to make it pseudonymous. So it really doesn't come for free. You have to do more encryption at a certain level. You have to do a few more things. So for example, and I didn't go into all the details there, but rate limiting becomes a bit more challenging when you don't recognize the people. Like, you don't recognize your attacker between two requests because you lack the metadata. You don't know who it is. So one of the properties, for example, is that you never have the same identity in two different groups. You appear as two different users to the system, even though you are the same user. So this is where it gets more complicated to prevent abuse and spam. And so one of the solutions there is to use something like Privacy Pass, which gives you tokens that are essentially anonymous, but they're limited, so you can spend them on operations without being recognized, but you can only spend as many tokens as you initially received at a time when you were in fact not anonymous. Stuff like that. So we don't have the luxury where we start with very little metadata and then we add it for enterprise users. It's simply not the reality we have in front of us right now. Yes. Go ahead, Roman.
Sorry, it just took a long time to mute. What do you see for consumer services that want more information for spam or abuse prevention, that is perhaps selective, like in the case where somebody said, I think this is spam, or somebody reported or blocked a user? Do you see that discovering, like, basically recorrelating a bunch of sessions that were pseudonymous using different identifiers? Do you see that as a sort of a feature or a property that may be required? Do you see that as something that might need to be included in the protocol? And if not, like, what would be the response to somebody who wants to have good spam or abuse prevention?
Well, I mean, the understanding right now is that you can address all these scenarios. Because if somebody, I don't know, contacts you and you want to block them, you can still do that, because at that point you see actually their real identity. The user is not going to be pseudonymous to you. And then you can also report that user to the system. And then the system can do whatever it wants with that report. That's not really something MIMI should solve, but what it can do in practical terms, it can, limit the amount of privacy pass tokens that user gets, or terminate the account or whatever.
Well, I mean, like an obvious way to go solve this problem, if you were sure that it really was spam, would be to then reveal all of the other pseudonyms to the other system, so that they could go and basically kick them out of those other groups. But that's do that. But like, basically solving the problem for a single recipient isn't really very good. Like what we want ultimately, what some of these providers probably want, is the ability to take information that that some user account was used for spam, and use that to go and help other people who are recently communicating with the same real user.
Yeah, so that works with privacy pass. So the privacy pass issuance is at the user level, very much not anonymous at all. So if that user has been flagged for misbehavior, it will not receive any new tokens, and then it might still have some left, but it can spend them and generate a little more spam, but it'll run out of tokens very soon and cannot receive any new ones. So that's essentially how we prevent that across groups. Yes, Travis.
Yeah, sorry. Yeah, microphones are taking a long time to unmute today. Just out of interest, is this stuff written in a draft, either published or unpublished at the moment, just for further reading?
We have a bit more. It's not completely finalized. I mean, the idea would be to bring that to the delivery service document as we flesh it out more. And whatever version we have today will, of course, not be the final one, because there will be discussion. There will be things that we have not really thought of. But yeah, the ideal way for us would be to bring that into the working group as early as possible. So yeah, to answer your question a bit more from before, Ron, we have to do some serious threat modeling, which we have already done, but it's probably not exhaustive, and see what all the possibilities are, and see if we have the right tools to prevent that, and understand if we are in a worse place than, say, in a system that had no encryption and no metadata protection at all. We can still do message franking, for example, what Facebook Messenger does, where you can flag messages and stuff like that after the fact when they're revealed. So users can still de-anonymize other users in the context of an abuse scenario. That's absolutely possible.
So it sounds like a path forward here might be to start a draft that does the threat modeling that you were just discussing, right? So that the working group can better understand what are the capabilities we need in terms of moderation, and thus ensure that the necessary metadata does get provided in the protocol.
Yeah, I think that's a good idea. Yeah.
Are you volunteering to do that draft as well?
Yeah, I would. I would definitely contribute. I can also get it started. It would be interesting if more people would contribute to that. But since we have done some prior work here, we are in a good position to get that started.
Anybody else in the room who'd like to help with that document?
Yeah, if my microphone would unmute faster, I can probably help out. Feel free to ping me offline.
Cool, thanks.
I can never say no to a request for help, so you can also count on me in small and big ways.
Excellent. Thank you, Mary.
Awesome.
Bless you, Mary.
This is good. It's good that we have some action items because as chair, that's how I get evaluated, is whether we're handing out work to people.
I mean, Conrad, maybe you want to say a few words about the threat modeling. You were the one working on that more than myself. Before I promise too much here about prior art.
Sorry, can you elaborate on the scope of it? Like, do you mean the threat model on the just metadata in general? Sorry, I want to.
The idea is to start a document with a threat model that is specific to abuse scenarios in the messaging system, and to use that essentially to benchmark the metadata minimizing version to see if we miss out essentially on some stuff because we have less metadata now.
Ooh, I have to say I'm not super well versed with the current state of the art. You mean the franking stuff that you mentioned earlier as well? I did really have to look into that, but I'd of course be happy to start something. Yeah.
Yeah, sure. I mean, the franking stuff, I just mentioned that for the sake of completeness. But what Rowan said, like blocking users, when is that important, etc. What effect does it have? What desired effect should it have, etc. And then can we still have that effect when we have less metadata?
Oh, you mean the stuff on anonymous credentials, blocklistable anonymous credentials?
Well, in that particular case, privacy pass does a trick, but the
sure.
document is about the threat modeling, and since we did some threat modeling in the past, we could potentially
yes.
reuse some of that. That's the point here. Not provide the solution, but state the problem first.
Okay, so it sounds like further discussion here will happen as that draft gets drafted. So does anybody have anything else on privacy for metadata? Otherwise, we're at the end of the agenda for today. The official items. We have 15 minutes left on the clock. So, is there anything else anybody would like to discuss today? Because if not, I think we can give everybody back 15 minutes out of their day, which is always, for me, a good outcome of any meeting. All right, no takers. So I think with that, sounds like we can wrap up for today. Oh, sorry. Go ahead, Rowan.
Oh, I was just going to say, like, unmuting, preparing to say goodbye to everybody.
Fair enough. Yeah, it is weird how long that takes in Meet Echo. Okay. Thank you, Raphael, very much for leading all the conversations today. Very much appreciated. And thanks everybody for attending. So yeah, we have another one of these scheduled. Another one of these interims that is scheduled for June. Hang on, where is it? Sorry, for Wednesday, May 31st. Since we got through everything today, like there's nothing officially on the agenda just now, but of course, feel free to contact the chairs, myself and Alyssa, if you want to discuss anything in that session. And of course, we'll talk about it more on the list as well. All right.
Bye, everybody.
Cool. Thank you very
Thanks,
much
everyone.
for taking the notes and drawing the slides. See you in 2
Oh, yeah,
weeks.
sure.
Thank you.
So long, folks.